Hi everyone, so I'm going to start doing a few step videos. I'm going to try and do one a day, actually, one question a day anyway. It'll be from random step papers, sometimes from step 3 because a student of mine's doing step 3, sometimes from step 1 like it is today because a couple of students I've got in year 12 who I'm trying to encourage to do some of the extension questions, and step 1's a great place to start. It really is. The old step ones from like 2000-ish, the 2000s, 2010s, they're really good in terms of like introducing you and preparing you for step 2 and step 3, but also for the mat. They're perfect. They really are. I think just getting used to that kind of being asked questions in different ways. Now, I mean, this is a good example really of a question which is not that bad. It's heavy on the algebra. It will get you used to like developing more like patience for long algebraic problems. And actually, though, in terms of like a genuine, like sort of like insight, there's not too many really tricky bits if you see what I mean. Let's go through it anyway. Okay, so let's have a look at part one. So we're told A has coordinates 5, 16 and B has coordinates minus 4, 4. Well, that seems quite straightforward. And we're going to try and we're going to define the point P such that P moves on a path so that AP equals 2BP. Now they're clearly talking about the length of AP is double the length of BP here, and we've got to find the Cartesian equation. Now this is like a loci question with coordinate geometry really, because we're looking at something which moves on a path, but really I can't really see much else to do here other than say, well, okay, let's try and find the length AP. Now the length AP is simply going to be the square root of x minus 5 squared plus y minus 16 squared. That will find us the distance from A to P. I'm going to do the same for BP as well. BP, well, that's simply going to be the square root of x plus 4 squared plus y minus 4 squared. And as AP equals 2BP, I'm just going to go with that and say, well, okay, this one is double this one. I need to double this one to get to this one. And so, okay, what are we going to have there? We're going to have the square root of x minus 5 squared plus y minus 16 squared equals 2 times the square root of x plus 4 squared plus y minus 4 in brackets squared. Okay. Now our job, I guess, because look, I've got an equation, it's just got x's and y's in it. Always look at what you've got and what you're heading towards in maths. That's just good advice. I've got just an equation with x's and y's in it. It looks like it's got x squareds and y squareds as well after I multiply the brackets. I just need to tidy this up, and really the most natural thing to do here would be to square both sides. So we've got x minus 5 squared plus y minus 16 squared. Now let's try and do two things at once here because it does help ease up on the algebra. Square root of 2, you're going to get 4, and then you're going to times it all by that with the square root undone. So we're going to get 4x plus 4 squared plus y minus 4 squared. Okay, let's multiply it all out. X squared minus 10x plus 25 plus y squared minus 32y plus 256. Remember, you don't get a calculator for this exam, so you want to get good with your arithmetic. We're going to get plus 4x, which is plus 8x times by 4. We're going to get 32x. And then we're going to get a 16 times 4 is 64. Similarly for the y, we're going to have very similar result here. Y squared minus 8y plus 16. Okay, let's put it all on one side. X squared, 4x squared minus x squared is 3x squared. And then I've got 32x, but I'm adding 10x to that, so that's 42x. Tick as you go, actually. And then we've got 256, but we've got 100 and... oh, hang on, look at that. Little mistake there. You've got to times that one by 4 as well. Did you notice that? So that's going to be a 4y squared, and that's going to be a minus 32y, and that's going to be a 64. That's better. It's error correction is part of this, isn't it? Like you've got to kind of like and this is advice I really take myself, but check each line of working after you've done it, or at least the last 2 or 3 lines, because it saves you like fruitless hours, like where you're just like confused about what you've done wrong. Okay, so what have we got here? And by the way, the reason I detected that is because I thought, well, I'm going to have to divide this all by 3. So why am I not getting a 3y squared? Because that's the only way I'm going to get to x squareds and y squareds on their own. So I knew that there's definitely something going wrong. Okay, we've got 128 on this side, take away 256, 256, you'd have minus 128. Take away another 25, you'd have minus 153. So that's that one, that one, that one, and that one dealt with. Do that arithmetic carefully though. Okay, plus 3y squared, that's that one and that one dealt with. And then I'm going to be completely losing the 32y's by adding 32y. Oh, I've dealt with this one, I've dealt with this one. So it looks like it's all been dealt with. Okay, cool. Divide it all by 3. And complete the square because we're turning it into a circle. And that's a standard technique, isn't it, for a circle? And so we end up with the result 100 equals x plus 7 squared plus y squared. So it's a circle, centre minus 7, 0, radius 10. There we go. Cool. So that's the first bit done. Now, this is also good practice for the second bit, because one of the things step questions regularly do is teach you, in many ways, in part 1, how to do part 2, or at least suggest, like a method. And here, really, what they've done in part 1 is they've given you a value of k. Here, it's like 2, but here they're giving you the value as k. So, I could expect, basically, I'm going to do exactly the same thing. So C is A0. And D is B0, and Q is a point xy. Let Q equal xy. And then it tells me the variable Q moves on this path, where K is bigger than 1, and then it tells you, given that the path of Q is the same as the path of P. Well, if the path of Q is the same as the path of P, that still holds, essentially, like it needs to be a circle, radius minus 7, 0, centre minus 7, 0, radius 10. So it should be exactly the same as that. So let's give this a go. We're going to just try the same way as before, because QC equals KQD. Well, the length of QC is going to be the square root of x minus a all squared plus y squared. Likewise for QD, it will equal x minus b all squared and y squared. But we're going to make this QC equals KQD. So if I just square it out straight away as well, I'm going to have x minus, well, actually I won't rush it too much. Let's just say, so hence x minus a squared plus y squared equals k root x minus b squared plus y squared, and I'm going to square both sides. Okay, so what do I get? I get x minus a squared plus y squared equals k squared x minus b squared plus k squared y squared. Now, where are we going to go from here to get their result? Well, their result is independent of k, which suggests that they've in some way made k the subject or found some kind of equation for k to eliminate it. Now, the other thing I'm thinking about is, the one thing I haven't used is the fact that this should be equivalent to this if the path of q moves on the same path as the path of p. So what I'm going to do, this is just my thinking basically, is I'm going to need to equate coefficients, yeah? What I need to do is I need to group the x terms together and group the y terms together, and then in some way equate the coefficients in terms of k. So what I'm going to do is I'm going to multiply out x squared minus 2ax plus a squared plus y squared equals k squared x squared. Now you'd have minus 2bx but times by k squared, so minus 2k squared bx plus k squared b squared plus k squared y squared. So lots of k squareds there. And then I'm going to put all the x terms together and all the y terms together. So I'm going to put a big 0 on this side. So I'm going to get x squared multiplied by k squared minus 1. That's that one and that one dealt with. And then I'm going to have plus x times, I'm actually going to leave some of the common factors in here just so I can see it clearly. Now I'm going to have 2a minus 2k squared b, and that's that one and that one dealt with. And then I'm going to have, for my y's, I might as well do the y's next, I'm going to have y squared multiplied by k squared minus 1 again, so that's that one and that one. Then I'm going to have all the junk on the end, that's this term and this term, so I'm going to have plus k squared b squared minus a squared. Cool. Now, if I want to make this one look like this one, what I might quickly do with this is multiply it out again. just so I can see clearly the coefficients on x squared, x and y squared, and make it 0. So it looks more like that one. I'm just trying to make the shape of both of them exactly the same. Because now I can say, okay, well, firstly, let's divide through by k squared minus 1. We can do that because k is bigger than 1, remember, and you do want to check that you're not dividing by 0, but I said k was bigger than 1. So I'm going to divide through by k squared minus 1. That's what I'm going to do. So I get an x squared, I get an x times by 2, I might put it like this actually, 2a minus k squared b over k squared minus 1, and then I get a y squared, and then I get this ugly business on the end, k squared b squared minus a squared all over k squared minus 1. Now the reason I'm doing that is because I can now use the principle of equating coefficients. Yeah. In other words, I'm going to match up the coefficients for both of my equations. Yeah. So I can see on the x they've got a 14. This equals a 14. So 14 should equal 2a minus k squared b over k squared minus 1. But likewise, minus 51 equals k squared b squared minus a squared over k squared minus 1. Yeah. So, okay, what am I going to do next? Well, I'm thinking this has got k's, a's and b's involved, and I'd like to get rid of the k's, and that's what I can do with two equations. I can put them both in terms of k squared by the look at this, because all the k's have been squared, and then I can match them up. So I'm going to have 14k squared minus 14 equals 2a minus 2k squared b. Put the k squareds together. I'm going to have k squared multiplied by, and I can divide everything by 2 actually here, so let's do that first. 7k squared minus 7 is a minus k squared b. That makes the algebra slightly nicer, doesn't it? Then I can say k squared 7 plus b, yeah, that's from adding that onto that side, equals a plus 7. And look at this, I get k squared is a plus 7 over b plus 7. Now I'm happy with that result because look at what we're trying to prove. Yeah, it appears in the answer. Let's do the same over here for this one. So I'm going to times that across. I'm going to have 51 minus 51k squared equals k squared b squared minus a squared. Put the k squareds together again. So I get k squared b squared minus 51 equals, so I'm putting that, which way round am I doing this? Let me just remind myself. Oh, look, sign error. It's easy to make sign errors in this, but when you know the answer, at least you can easily find your mistake, because we do know what we're trying to end up with here. So add that onto that side, add that onto that side, we get 51 plus a squared, and there we go. We've got k squared is, and this looks familiar, a squared plus 51 over b squared plus 51. I'm pretty sure that's what we had up here, isn't it? Yeah, so at the end we can just say as k squared is this, k squared is that, we can combine and just say hence a plus 7 over b plus 7 equals a squared plus 51 over b squared plus 51. Yeah, cool. Okay, we're almost at the end now. We've shown that that's the case. Show further that this is the case. Now, they haven't given us any extra information. You might think that maybe something exists bit earlier in the question, but actually we just got to rearrange this. We're just going to times that across, cross multiply, ab squared plus 7b squared plus 51a plus 7 times 51. I could work that out, but I think I'm going to get 7 times 50 on the other side, and it's going to cancel, so always look ahead at where you're going. Here you're going to get a squared, please, plus 7a squared plus 51b plus 7 times 51. Yeah, oh, look at that. We didn't even have to work it out. Okay, now, what else cancels? Anything else cancel? I don't think so, but we can bring it all onto one side and factorise, always factorise. Now, you can take out an AB here and have an A minus B left when you take that onto this side, because AB squared minus A squared B is AB times A multiplied by AB times minus B. That will give you A squared B minus AB squared, which is what we're going to have over here. Let's just check we've got it the right way round here. I think I might have done it the wrong way round. It depends which side you're taking it onto, of course. But if I take everything onto the left hand side, then I'm going to need a B, and then I'm going to need a minus an A there. Likewise for this bit, I'm going to do 7b squared minus 7 b squared minus a squared but that of course is difference of two squares, so it factorizes to give me that. And then lastly with the 51s, we're going to have plus 51 a minus b, and that should equal 0. Now remember, they did say in the question that a doesn't equal b. There's a really good reason for that, because if a doesn't equal b, if a does equal b, I can't do the next trick. And the next trick is, let's just turn all these around, yeah? I've got b minus a. Here, this factorizes to give me b plus a, b minus a. Oh, look, there's another b minus a. And obviously I can turn this a minus b around and make it minus 51 b minus a. Yeah? You're always allowed to do that, aren't you? Like the negative of a minus b is b minus a. Yeah? And so, yeah, the negative of b minus a is a minus b. You're always allowed to switch that round in a bracket. Okay, we can now divide through by b minus a, and we get ab plus 7a plus b minus 51 equals 0. And to factorise this, well, we need two numbers that add to give well, can you just see now that this is going to give you a plus 7 times b plus 7. Take away the 49, take away the 51, and it equals 0. You know, always look where you're going as well. Look at where we're going. We're going to this, and if you multiply that out, you can see that you're going to basically multiply it out, take the 100 on one side, you can see that you're going to end up with this. So, you know, we've got a lovely little result here, and we've proved it. There we go. And that's one big step question done from 2005. Now, you know, look at what you've done there. What was difficult about that? Well, the way the question's worded is probably unfamiliar. How much algebra you have to do to get to the answer is probably unfamiliar compared to a typical A-level question. Step takes a lot longer. But other than that, I would say there's not really many steps in a question where we've done anything too unusual. Equate coefficients, very common question. Difference of two squares, we love that trick. But, you know, this is obviously a longer question than an A-level question. But I hope it shows you that step doesn't need to be, step isn't necessarily impossible or anything like that. It really isn't. You can do this, you absolutely can. Anyway, hope the video was useful. Keep up the hard work. Bye-bye.